So let us see now Townsend's current growth equation considering primary and secondary ionization. Earlier part we discussed Townsend current growth equation considering only primary ionization. Okay, if we consider only primary ionization, that means we are just considering initial electrons near cathode are there, and then number of collisions will be there with gas molecules only, and electrons will be liberated from the gas molecules only. Okay, but when we will consider secondary ionization, that means here we will consider, suppose one electron is moving here in the gap. When one free electron moving, it will collide with the gas molecule and number of electrons will be liberated. So this part will be also considered, and then this remaining positive ion will be having attack on this cathode surface and secondary electrons will be also liberating. So only change here we have to do, initial electrons will be electrons near anode N0 will be changing, and we have to consider N0 in terms of N plus also. So N plus means electrons liberated due to positive ion impact. Okay, so just we will consider, this is derived already part. Current I is equal to I0 e raised to alpha d. This already we had derived in earlier session. If any doubt is there, you can see that video lecture considering only primary ionization. So let us start with this equation. Okay, now we will see that how this equation will become I is equal to I0 e raised to alpha d into bracket 1 minus gamma into bracket e raised to alpha d minus 1, where this gamma is Townsend's secondary ionization coefficient. So considering both primary and secondary ionization. So here again take N0, write down in your notebook, and then you will do some step, then only you will understand the equation. So let N0 will be the number of electrons released from cathode due to ultraviolet radiation. As usual, N0. Here are the number of electrons released from cathode due to ultraviolet. Means always I am starting with this initiating electron now, and I am telling that that is due to ultraviolet radiations or this illumination. So this N0 we are assuming. Okay, initial. Now let N plus be the number of electrons released from cathode due to positive ion bombardment. Already I explained positive ion will have impact on this. So let N plus means N plus. These are secondary electrons means N plus. So let the number of electrons liberated due to impact of positive ion be N plus. So this is due to the bombardment of positive ion. And now let Nd will be number of electrons reaching anode. As usual, we are consider N0 will start and it will become Nd when it go cross over the gap distance d. So Nd is number of electrons reaching anode. Now gamma, here we will use gamma. So write down. Gamma is Townsend's secondary ionization coefficient. Now how we have defined this Townsend secondary ionization coefficient? Number of electrons released from cathode per incident positive ion photon metastastic. What is the meaning of this? When one positive ion will have impact on the cathode surface, then how many electrons are liberated in this figure? I have just shown you one positive ion impact and 4 electrons I have shown here. It means that gamma I have considered here 4. So what are these 4 gamma? Number of electrons liberated by a single positive ion. Okay, by a positive ion. So Townsend's secondary ionization coefficient means number of electrons released from cathode. Released from cathode per incident means per incident. म्हणजे एक positive ion impact. So only one positive ion impact. It might be photon or metastable. So now our Townsend's primary ionization, see I is equal to I0 alpha e raised to d. We will start with that equation. Okay. So that is Nd is equal to N0 e raised to alpha d with number of electrons. Now here this equation which we derived earlier. So here we will not say N0. But we will say initiating electrons are not N0. But that are N0 plus N plus. Because what? Here initial electrons N0 are due to radiation and N plus will impact due to the positive ion impact on the cathode surface. See this figure. So what are now initial electrons near cathode? They are N0 means liberated by radiation and plus N plus. So N0 plus N plus electrons are there near cathode. N plus are also there, N0 are also there. Only that is the change. If we will understand this by conceptual, then no problem. Then all is mathematics. Okay. So we have to just consider now initiating electrons are N0 plus N plus. So this N plus is suffix. Okay. N0 plus, this is addition, and this is suffix means liberated by positive ion impact. So here N0, N plus are the number of electrons at the cathode. Now if initiating electrons are these, how many electrons will be liberated by positive ion impact? Now that will be into gamma. Why? Because gamma is what? Gamma is when only one positive ion impact will be there. Then it will liberate some secondary free electrons, 4 I showed. But if for one positive ion impact, but total electrons liberated will be this additional electron into gamma. Okay, so N plus will be equal to Nd minus N0 plus N plus into gamma. So this is the equation actually, because what will be the electrons liberated positive ion due to positive ion? We have considered electrons near cathode anode are Nd. So how many initial electrons here are N0 plus N plus. Initial electrons now near anode are this, and reaching the anode are Nd, and these are cathode. So what is the total electrons have changed added due to positive ion impact? So that will be Nd, last electrons which are higher. So Nd minus initial electrons N0 plus N plus. Definitely these Nd minus N0 N plus electrons are liberated from the gas molecule. Okay, and that electrons are liberated means that many positive ions are there, that electrons will be colliding with this, and therefore into gamma will be total electrons liberated from the electrode, cathode surface. If you understood this, okay, otherwise ask me the doubt again. So here I am saying if one positive ion impact will be there on cathode surface, it will dislodge some electrons. But how many positive ions will have impact on this? These are positive ions, and therefore total electrons liberated from the positive ion impact are these. Now just write down this equation and solve this equation. Try yourself. Okay. What will be the done steps? I will ask you tomorrow. I will continue tomorrow, because already I said this part is very important. You ask me part A, if doubt is there, you ask me part B. Okay. And then tomorrow we'll continue this derivation, but try to do some steps before that. Now here in books also I have written like this, nobody write in book. So solve the bracket, only you solve this bracket, just multiply with gamma. So it will be gamma Nd into gamma N0 plus gamma into N plus. Solve the bracket, and then we just take this N plus here, because we are solving now N plus. What will be the actual electrons due to positive ion impacts? And that again we have to substitute in the equation. Okay, so solve the bracket, take N plus on left hand side, and then N plus you find out. Okay, so let us continue that in tomorrow's session. If any doubt is there up to this part, you can ask me. Doubt असेल तर